Johannesburg, how are we doing? Good, yes, okay, good. We had a whole dev conference. It's been a while, right? It's been a while. It's been 2 years of whatever trauma we've been going through, and finally we can all sit in the same room and talk about stuff. I never thought that would happen, that us devs would really want to talk to each other again, but I found myself longing for it. I got very annoyed just screaming at a screen, you know. Particularly during a talk, you've got to do a presentation and you're just getting angry, I don't know, at the plants or something behind you. So today we're here, and I'm very, very happy that we're here, and well done to the DevConf team for organizing this. It is very exciting. And we're here to talk about AI and how we don't need it. A little bit of background about myself is that I have been in software for the past 10 years, mostly as a developer, and at some stage, probably around 7 years ago, I moved into the machine learning space, specifically in the natural language processing space, which is basically machine learning for text. And through this, I worked on a number of clients, trying to deploy stuff into production. Back in 2015, it was a completely different world. There were no tools that you could just use for this. It was all very hacky, trying to get stuff. Things would fall over. No one would know why machine learning models were misbehaving. No one would know what to do about it. You get these weird bug reports that you couldn't really fix. And one of the things I saw kind of as a prevailing theme was how people wanted to shove AI into everything. So I'm going to take a moment to step back and ask, who is a data scientist, or would call themselves a data scientist? We've got a couple. This one's going to burn for you, this talk. Who has worked with data scientists? Cool. Who has worked in an innovation department where there are data scientists? Who is trained and deployed a machine learning model? Who is trained but not deployed a machine learning model? Okay, cool. Any project managers out here who have had to deal with data or planning on dealing with data on their projects? Cool, cool, cool. This one's for you. Hopefully we'll learn something through this. And so I've been working in this space for a while. I also co-founded an initiative for NLP. This is more of an NGO, so if you are interested in that, it's called Masakane. We focus on doing NLP for African languages. And I'm also a bassist at a band. You can follow my band. It's really weird music, but I always have to punt it a little bit. And lastly, I am head of data, or whatever they decide to call me there at Jade Abbott. Cool. So today we're going to talk about where we are, what this mess is that we've gotten ourselves into, how did we get there, and finally, what on earth are we going to do about it? So where we are. And if you've been kind of monitoring this hype cycle of AI, and I'm going to use the word AI very broadly, I'm going to use the word machine learning very broadly, I'm going to use the word data science very broadly, because to be frank, in industry, everyone just bumbled them up anyway. Occasionally you get these slides that try to describe them, and then people continue to misuse them anyway. And so where we are is, this is 2020. 2 years nowadays feels like quite a long time. In tech, it certainly is. But 2020, there was a really large report. This report was by BCG, as well as MIT Sloan. So if you're involved in kind of the more management consulting side, you'll recognize these two names, BCG being one of the top 5 consulting firms, and MIT Sloan Management Review being one of the large publications. And in 2020, despite all this hype, they declared that 10% of companies obtain significant financial benefits from artificial intelligence technologies, which is a little bit surprising. So if we take a couple years back, we can look at how we got here. And so let's look at 2011. 2011 was important in that McKinsey & Company released a report entitled Big Data, the Next Frontier of Innovation, Competition, and Productivity. Right? And here they made these broad, very sweeping claims: 300 billion value in US healthcare, 600 billion in consumer surplus of location data, 250 billion in euros in the public sector in the EU. And so, I'm going the wrong way. Sorry, thank you, Cliff, for the clicker. And so let's go 5 years ahead of that, right? So next 5 years, 2016. And now we've got another McKinsey report, The Age of Analytics, competing in the data-driven world. You laughed. You're going to laugh a lot in this presentation. Only 50% of the value captured in location data, only 10% in the US healthcare, only 10% in the EU public sector. So that's a little bit disappointing, but at least they owned up to it, I guess. This one, 2 years later, Gartner, also one of the big publications in that space, they actually, in their official publication, they said failure rates of data science and AI projects was 65%. Nick Utica actually tweeted, he worked at Gartner at the time, he said failure rates were actually closer to 85%. That is a terrifyingly large number, right? And then just a year later, so now we've just had this dismal report, just a year later, McKinsey and Company once again. Notes from the AI frontier. Thanks, McKinsey. Modeling and the impact of AI on the world economy. Okay, you got AI has the potential to deliver additional global economic activity of around 13 trillion by 2030. And so here we are, and I don't know about you. 2020, only 10% of companies obtain significant financial benefits. And I don't know about you, but I don't know what the frack is going on. I'm a little bit confused. What are we saying? Is it useful? Is it not useful? Who's making this money? Because it's certainly not majority of the people who are trying it out, right? And so if you're a data scientist in this field, or you've worked with data scientists, you felt some of this burn. And a lot of that burn, I'm going to talk kind of generically in terms of the people who reported on these statistics. I blame the top 5 management consulting companies. We're going to, call them broadly the firm. Maybe we'll call them, ooh, that's gone, the firm. The firm. Maybe the firm and company. We'll go past that one quickly. We'll go the firm. And so what the firm do, I don't know how many of you have worked with the management consultants. I think a lot of us in Joburg have, because many of them are based here. But they provide something called strategy, right? Strategy as a service. You pay them millions, and they come swooping in with their strategy that they develop for you and launch you in the form of PowerPoint presentations, which you can then take and get someone else to build it for you. They don't build anything. So that's the firm. And so you can imagine some poor business, probably not that poor, probably wealthy since you're hiring them in the first place. You come to the firm and you say, hey, what is our strategy? What is it? Well, the firm says you need to data science and AI. That's what the firm says. And we remember when that time happened, when the firm said this, because suddenly everyone was recruiting data scientists like hot potatoes. I don't know if we recruit hot potatoes like data. It was a very misplaced metaphor. Either way, they were just being recruited all over the place. And then 5 years later, same company comes back to the firm, says, the firm, why are all our data science projects failing? We are not seeing any return on investment whatsoever, and we've spent millions and billions on this. And so what the firm does is they rebottle up that strategy they gave you 5 years ago into a new thing, and they sell it back to you. They say, you know what you need? Hire us, we'll bring you more strategy. And so how I got to all this entire thing is not just because I'm angry. It's because I went and read all their docs, all their reports, all their everything, and only thing that was consistent. They maybe give a hint here or there of something they may have learned along the way, and one use case, they'll point at one place that was successful, and the rest of it was like, what you need is more strategy. Who can provide strategy? Only us. We'll come help you with this. Which is like a little bit ridiculous because no one actually knew how to do it. How could you be selling strategy for this thing that no one knew what was going on? So what you end up is with this bit of a backwards causality is they find the one use case where it worked. Uber, something. We'll be the Uber of blah. Company X did Y and they're successful, so if you do Y, you'll succeed too. But this is not how that works, right? Just because you do the exact same thing as another company, if the context differs, you're probably not going to succeed. There's no causal relation. And so we're going to take a little bit of a side step into the world of strategy, right? As devs, this is not something we particularly look at quite often. We might look at it from a project management perspective to understand, how we could strategically build an architecture, for example. But typically strategy, business strategy, is something that is owned by the managers and the mid-level management and the top-level managers, C-suite management. And it's something that's owned by MBAs, right? If you go do an MBA, which you pay lots of money to do, that there you learn about strategy sometimes. And if you go hire one of the top 5 consulting firms, which means you've got to have a lot of money. And so I was lucky enough on one of my trips to come across a really cool group of people who aim to democratize strategy. And they come from like the open source DevOps kind of space. And their goal was like, cool, we hate the consulting firms and what they've been selling because they're still holding on to the product. They don't provide the tools of how they came up with your strategy. And we want to come up with tools that make sense, and we want to be able to explain them, and we want to publish them openly so that everyone can learn and benefit from them. And so they're kind of like, you know, they come from software engineering. They're people that we know and like. And they hit these things as they grew throughout companies and got like a little bit more senior. And they realized they were like, cool, the strategies I have, the strategy, I had to read some book by some guy at Toyota, and now apparently I know how to do business strategy. You know, it doesn't actually work like that. And so we're going to have to understand a couple of concepts. The one we're going to talk about broadly is called Wardley mapping. But to start off this discussion, we've got to understand one key thing. We're going to start with something called the Toaster Project. And the Toaster Project, or a heroic attempt to build a simple electric appliance from scratch, is a guy who literally wanted to build a toaster, but not from like, you know, nails and elements and those sort of things. He wanted to build a toaster from the ore that you got in the mine. He wanted to take that ore, he wanted to process it, he wanted to find the ingredients to make plastic and then, you know, do that. And the long and short of the story is that he went through all this effort. It took a very long time, it was very expensive, and he got to the end of it and he turned the toaster on and it exploded after 5 minutes. And so the lesson that we learn from this is that innovation builds on top of commodities. What is a commodity? A commodity is a part that's so well refined. A commodity is electricity, it's water, it's the screws that you buy, it's the plastic that you can find, the molds that all these things are commodities. To understand this a little better, we're going to jump into the first thing about Wardley mapping. I would usually jump off the stage, but apparently then the cameras can't see me, so maybe I'll go all the way to this. I'll stand here, it'll be fine. I could probably point with this thing. Yes, I learn new things every day. So we start at Genesis. So any product, this is the evolution of any product. It's kind of generic. Start at Genesis. This is where, you know, things are a little bit crazy. We'll go into a bit more detail in a moment. Then you become custom. If you work in, you know, most consulting houses now, you're probably doing some custom software. Then you work on a product. This is when you understand the market a bit more. And lastly, you work on a commodity. So kind of more in detail. Genesis, you've got an undefined market in terms of who wants, and this is maybe something completely new. Back in the day, it was AI, but frankly, it's any trend. These days, probably Web 3.0, the vibe, or whatever. It's confusing, exciting, and it's unstable because you don't really know what to do with it. Custom, you've got a forming market. This is where you're seeking profit and return on investment, and you're learning from others in the space. When you got a product, you got this growing market, you got high profitability, and like your competition is around feature comparisons, whose features are better than others. And then commodities are like very mature. They're focusing on the value and they're focusing on operational advantage. So here it's like, you know, the fact that you can save, you know, milliseconds off a certain, manufacturing line, for example, can result in really large improvements, or like tiny millimeters of something or another can result in that. That's what a commodity is. And so now we're going to move into the next part of what we call a Wardley map. Just to give heads up, Simon Wardley is the guy we're talking about. S. Wardley, he invented Wardley mapping. He's got his book published on Medium because he didn't want to, as he wanted to democratize it, he wanted to share it widely. So just note that and go check him out. And all his friends, they've got a thing called Map Camp. It's great. And so we've now got this, we've done our x-axis, we're now going to do our y-axis. We've got the value chain, and how the value chain works is at the top you've got your users, and you've got, your user has some needs, and in order to fulfill those needs, we have some activities, and those activities depend on other activities. Pretty straightforward. Let's do a real example. You've got a user wants to be able to do online customer support for something, whatever that might be. Let's say they want to build someone decides in order to fulfill this need, we're going to build a chatbot for some reason. We'll not argue about that. Someone wants to build a chatbot for it. And in order to build that chatbot, you need access to an API and you need access to compute. Cool, so now we combine them, and this is what is a Wardley map by definition, where you've got your product evolution on the bottom and your value chain on the top. And it looks a bit like this. So you'll have your user at the top. You're building a custom online customer support tool. Let's say you're going to build a custom chatbot, and that's reliant on an API, which is already a product, which is great, and some compute, which is already a commodity. The way compute these days, cloud compute, I see as a commodity, right? We rely on it so much that it has to be. We've got SLAs for it. Yeah. And our strategy as a business could say, cool, well, we see a lot of people with this need for online customer support. How about we build like a cool, online customer support specific chatbot product that other people can use. And that's really your value add, is taking something that's in the custom space and moving it to the product, or taking something in the product space and turning it into commodity. And the reason we're able to do this so easily is because everything that we're relying on is already further down the commodity chain, already further down the product evolution chain as us. Cool. Stay with me. I promise this is relevant. Here's another example. Once again, I'm using kind of data AI-related topics here for a specific reason. So let's say we want to do simple home insurance quotes. Simple home insurance quote, perfect example. I've seen many clients want this, insurance clients. They want you to be able to take a video of your house, and then it automatically identifies what's in your house, and then it gives you a quote. Cool. And so to do that, we want some special computer vision app, and we need some custom backend, and we're going to rely on some SDKs and the computer vision API, probably a general purpose one, like something that Google or Azure or AWS might provide. Obviously, that'll rely on something like mobile phones and compute and big image data, right? So the computer vision API you're using was probably built on the internet worth of data that they've managed to label. Right, it's built on something that is actually very big and general, and to me is almost a commodity, because the internet itself is almost a commodity. But this results in a problem, and it's the same problem every time. Is that everyone I've seen, except maybe one, when they tried to do this, they found that the general computer vision API doesn't work. You know why? This data is contextual. The things that we have in our houses aren't necessarily the things that they have product tags for. The things, even the lighting that we have in South Africa differs from certain places in the world. And so that where it works as a very high % accuracy overseas, it actually performs very poorly here. And so these general AI tools often fail. And they're getting better. I won't lie, they're managing to just pump as much data in as possible, and they've realized what use cases they're getting, and I think they're starting to evolve them. But it doesn't change the fact that data is highly contextual. And we see this when people build facial recognition tools, and they fail when they're brought to Africa because they've never been trained on black skin. We see this, frankly, all over the place. It's one of the big failures of machine learning is the fact that the data we train it on is highly contextual. Because of that, I'd argue that data resists commodification. It's hard to commodify data because it's always tied to a context. Now, I can sort of take electricity out of its context somewhat. I mean, South Africa is an interesting use case, and it'll still be electricity elsewhere. I can take a set of screws out of this, and if I transfer it somewhere else, that set of screws will still be useful. If I take data out of its context, it is meaningless. It is absolutely meaningless. There's absolutely nothing we can do it. And even within an organization, if you take it from another organization that is working in a slightly different sphere, there's very little that you can actually use it for without knowing what the context is. And so thus, I'd say data resists commodification. As a result, kind of as I've implied, your machine learning is highly contextual, and follows from that machine learning itself resists commodification. This is why we see so many computer vision and so many fancy APIs failing in production. It's because they were never context aware. They weren't aware of that they're working in our particular business, in our particular company, in our particular country, in our particular part of the world, time zone, whatever it might be. And so this is my argument about why many of these things are actually failing. Cool, so another example, I'm going to look at automatic fraud detection, another popular use case. So automatic fraud detection, you need some sort of platform, and you need some sort of custom AI model. So AI model there could be any machine learning model, could be something like that. And so we need data to do that, right? This is what machine learning is built on. Machine learning is built on data. And typically, we think the data should be a commodity, or even just a product. And when I say here, I mean within an organization, you have something that could be a commodity within your organization. It could be easily accessible. It could be highly optimized. But instead we find it's probably going to be some custom job. We're going to have to query some thing. You're going to have to know someone to find the data, to find the thing, to copy it, and give you a CSV, which you're now going to go process and figure out what happened. And more likely than not, it's actually at Genesis, you don't even have the data. You think you have the data. You look at it, you actually don't have the data. And so I like to think of this, remember this XKCD, very popular one. The programmer's excuse for legitimately slacking off is my code it's compiling. I like to think of the data scientist one, which is the number one data scientist excuse for legitimately slacking off is waiting for data. Because it's usually that way. And most data scientists spend majority of their time waiting for data to be unleaved so that they can actually do something. And that can take up to, I've seen anything from 6 months to 2 or 3 years to actually get access to data that they had applied for. So here's your poor data scientist. If you're a data scientist, you might see some of them already crying. Here we go. Do we have the data we need? That's the first question. Where in the organization does this data sit? Why is it taking so long to get access to the data? What the fuck are those fields? Jeff left. Jeff was the only person who knew what that was. Should I even have access to this data? There are personally identifiable fields in here. This data makes sense. How is it captured? We need labels or annotations. This is something from machine learning if you don't know. Who is going to annotate that data? Are those annotations even accurate? I have a whole talk just about how annotations are a disaster, so that's an argument for another day. And how can we be giving credit cards to 1-year-olds? I will let you linger on which bank that particular use case came from. But it's a real example. There's some more. There's so much data, how do we process it? And this is fine if maybe you came from a software engineering field, but more often than not, as a data scientist, you've come from statistics, you've come from engineering, you've come from a different field. What terrifying new format is this? The data is coming from 20 sources, how can I keep track? How the fuck do I query this? Why are data lakes so slow? Do you remember data lakes? Does anyone remember that? Are we still there? Have we moved past that? Please say we've, no, I'm just kidding. You're not meant to not. In Cape Town, people were like, yeah, I think we're past that. You're like, no, it's still there. I was like, oh gosh. Why are data lakes so slow? And what the fuck is a streaming architecture? And to DevConf, a lot of you guys probably might know what a streaming architecture is. As a data scientist, you shouldn't have to know that. You shouldn't have to know the underlying way in which your data is being moved to you in order to be able to access it. So this brings us back to the firm. Because this is all the firm's fault. Because what the firm failed to tell you, right, is that in order to get access to the data, you needed some blood sample from an executive, right? And that the fields named Beware the Leopard, some timestamp date time field. You spend 3 hours talking to a sysadmin trying to figure out what it is. But you know, they don't really want to delete it because it just might break some of the reports. You know? This is what the firm failed to tell us all along, is that this is what was happening underneath. And so that's a pretty lengthy description of the problem. And so now with the tools that I've introduced you to, with what we know now, how are we going to fix this? And I think we're actually doing okay. I see data science departments have now gone through a lot of this pain and are slowly coming out on the right side, at least I hope so. But if anyone is not, you know who to call. I'll go shout at some executives. So how are we going to fix this? And so this is kind of a realistic view of information, as I've described, where you've got your data probably in this phase. What the firm was trying to do is the firm was trying to convince you to move, commoditize the model. It was really good at providing Python libraries. I mean, upload some data, it'll evolve a model for you. Great. It's 3 lines of code to do that. But it doesn't matter, because if we can't access the data, it doesn't matter that we can train it in 3 hours. I know people who train models, and they're like, what was it trained on? What were those features? It's like, we don't really know. It's like, you know it works? We don't really know. I'm like, great. So glad we went through that exercise. What we really needed to be doing is focusing. And so the data really, in order to move the data along into something cheap, something that has the properties of a product or a commodity, is 2 things I think can enable this. One is data engineering, and the other one is data governance, right? And those are two frightening words for very different reasons. And so my first call to people who are doing this, I'm sorry if you are a data scientist, I'm sure you've learned a lot of skills by now that you didn't want to know, is organizations need to stop hiring them. Most organizations hired 200 of them, and they sat there for a couple of years until they left because they had nothing to do. And reasons for this is data scientists, I promise sparkle GIFs in the blurb, there are sparkle GIFs. Marvel at this MySpace aesthetic. They're usually these unicorns that have to know SQL and machine learning and ops and software engineering. None of these are the same thing. You know, and one person does not enjoy even doing those different tasks, right? Instead, what we need to do is start investing in data governance. Data governance is a very scary word. It sounds like more red tape. My beautiful picture, there we go. A lot of us think of it like this. Lots of rules and regulations, and that terrifies us as developers because we're like, oh God, people we have to meet with to make this work. Oh, you give me one of these. You're going to turn me off. Thank you, Cliff. Testing, testing. Ooh, this is more fun. Can I rip this off my face? So we've got more rules and regulations, and that's terrifying. But I invite everyone instead to think of data governance, and the way it should be implemented is your friendly librarian, right? Your friendly librarian has a data catalog, or your data librarian, we'll call it that. It's a friendly data catalog that catalogs all the data, understands data privacy, you know, you're not getting fields you shouldn't be having access to. They have able to track data quality over time, maybe improve it even. They understand data access, you know, you can check out data, so people know who is looking at certain data, which is important to know, actually. You should really know in an organization who has what data, but right now it's just in CSVs all over the place and no one has a clue. And they understand data lineage, which is like how data is changed over time. And so for me, in the words of Ru Paul, the library is officially open. And let's start investing in data governance. The next one is start hiring data engineers. And you can quote me on this. This is going to be, and still will be, the most valuable career path. I think if you're looking to move into a field which is going to earn lots and lots of money, it's going to be data engineering. What is data engineering? It's just this, except more. So if anyone is from the old school, there was a thing called ETL, which means extract, transform, and load. In data engineering, it's just more of the same, except there's lots more stuff and buzzwords and tools, and I don't know, it's a little bit messy. But at the end of the day, you're just extracting stuff, you're moving it around, you're loading it in. We can argue about the order of this. There's ETL and LET and LED, I don't know, every other one. And so start hiring data engineers is something that's very, very important to do. Next thing I like to talk about is from a quote by a fantastic human called Pelanomi Moloya. She is a data scientist at NetBank. And she says what she likes about the word data scientist is that it has the word data in it. It tells you what you should be paying attention to. I like ranting about the term data scientist because I'm like, yeah, what are scientists looking at if not the data? But she says they're even doing it twice. It's in the science thing and in the data thing. Look at the data. And so forget about the fancy models. Machine learning and data science actually these days are not about fancy models. Someone else is going to do that for you. It's going to be probably a machine. Maybe 3 lines of code, some abstract thing that's going to do it. And instead start caring about the data. What are the fields? Where did they come from? What are they filled with? What is the oddities in the data? Next, start caring about hypothesis testing. Because we are scientists, we need to care about testing hypotheses. There's no such thing. I think what people tend to do is they have a room of 20 data scientists and they throw data at them. They say, go explore. We want to understand insights. And I've been in the room when they've done this. No, tell us insights about your data. And I'm like, yes, but what is the business case? It's like, you'll find it. I'm like, how will we find it? We don't know what it is we're looking for. Whereas what we should be doing is understanding a little bit more about, you know, what the hunches that business have, and we should be using data science to confirm and disprove it. Disband your data science departments. You shouldn't be working isolated. There's no such thing as a data science department. What you should be doing instead is building interdisciplinary R&D teams. If you go to most large businesses, they already have R&D teams. They're probably filled with BI people. You should be there. You know, Build interdisciplinary product teams. We're already doing this. We're in software. We already have designers and product owners and all these different people on the team. That's where your data scientist should be sitting. And if you do this, you can actually enable data-driven decision-making in all teams. That means any product, right? Anything that you do, you can then start having a data lens on that. Now, this way that we see like a product owner and a UX person have become standard in the kind of software space. I think a data scientist should be in that space. And so here's my overly simplified diagram. I always have overly simplified diagrams of how this should look. I've got further more complicated ones, which I haven't put in here. But typically, you have business units. You know, this is the way it should look. Business units come up with a business hunch. They should send it to the R&D team. R&D team goes and proves or disproves it and comes back with a tested, validated business case. We take that validated business case and we throw it at the product teams, and maybe they can actually build something useful. And here I'm focusing on digital product teams. So obviously, I should lots of product teams. And both of these R&D teams and digital product teams have to go through the same data governance people. And they can use a data catalog. And data catalogs, when you find the right tools, are actually very helpful. If they're being well maintained by a proper department, they tell you exactly like where the data has come from. Other data scientists can flag issues with data that you are not even looking at. So maybe another team somewhere can flag something, and you can learn or know not to rely on that. And so I think that we had a big push for data governance by the firm. And yet we saw it being implemented in a very fragmented way, because I don't think there was enough dev buy-in. And I think if we figure out how we can best use it and we find the right tool, we can actually use it pretty well. And so, as with Mandla's keynote this morning, we were talking about our permaculture metaphors. I'm going with a data-driven fruit salad. And here we've got product owners, UX specialists, software engineers, data engineers, decision scientists. I chose to use that term instead of data scientists because we've heard enough about data scientists. It's all very confusing. Decision scientist is someone who helps make decisions using statistics. I find it a little bit more specific. They should be people-centric. They should be multidisciplinary. They should be agile. They should be like DevOps. These are all things that are standard. One thing I'd like to add is something called a data storyteller. Because right now what we do is we create graphs. It doesn't matter, graphs are not necessarily a story. They don't actually give the context behind the data. And so data storytellers are people who have usually got experience in either front-end or UX or kind of the data scientists who are good at telling that story. Data storytelling is a field I think will explode, right? So you know Spotify, that once a year Spotify gives you something? The people who build it are data storytellers. They try to tell you a story about you and your data, right? And we need that for any sort of data thing, not just graphs and dashboards and things, which frankly are mostly useless. And so what can we do with this information? What can we do? I always say I want to give this talk to CEOs. If there's a conference where CEOs go to, let me know so I can go shout at them. But what can we as individuals do? If you're looking to move into the field of data science, beware. I think there's going to be a lot of changes. If you are a data scientist, learn some data engineering skills. Also, work with management, push upwards, work closely with product owners. Do what you can from your position to enable these sort of changes, because otherwise you're just going to be upset. Like I was just very upset most of the time, unless I got to shout at someone, which was also at the end of the day upsetting, I guess. And if you're looking at studying this, maybe look at the other things that you can also study that you can do with it. Because I do think the demand for data science is going to go down. We're going to start seeing a lot of demand for like data engineers and people who can actually tell stories around data. So it's not all bad. I hope you had an excellent day. This is the last talk of the day. And remember to rate the speakers. You don't have to rate mine. You just need to rate the speakers. We do find it quite useful feedback. Try to be nice, be kind, even if you're going to be critical. I hope you have a wonderful Thursday. Any questions? If you have questions, I probably have to hand you a mic at this point. It's fine, we'll go back up to this. Oh, I've got one over there. No questions. Just one. There we go. Yay! Lebrand's got a question.
Hi, Jade. So thank you so much for your talk. For me, what really stood out is the difference between data scientists and data engineers. I really just thought that data engineers are just guys who are passionate about SQL.
I mean, a little bit like that.
No offense to anyone in the room.
I'm very passionate about SQL. So
And data scientists, more stats, maths, using that for decision making. So when you're saying companies should stop hiring data scientists and more data engineers, how do you ensure the integrity of the data in which they're making decisions on?
So don't get me wrong. They should have some data scientists, but they already hired too many of them who are sitting bottlenecked by the fact that they don't have data engineers. And it's a bottleneck, right? Because you can get hold of the data, but you can't get hold of the data consistently. You can't get hold of the data over time. If you're deploying machine learning models, you need to keep a constant stream of data coming, because if there's a shift, you need to be able to update the model. And without having data engineers bringing that data to you, it doesn't matter how many data scientists you have. They're going to be sitting, waiting around, waiting for data to happen. And so don't not have any data scientists, but since you've got a bunch of them and they're sitting around doing nothing, hire a bunch of data engineers because you've got a backlog. That's pretty much the thing. But yeah, you do need data scientists to obviously look at the integrity, and I also think data governance can play a role in doing that well, when implemented well. Anything else? Are we ready for food and drinks? Yes. Then I shall let you depart. Thank you very much for coming to my talk.